This is a solution to problem number 9 from the Chapter 1 review packet, and it's a mixture problem. We're given that we have a 15-quart radiator, and it contains a 40% concentration of antifreeze. So initially, this radiator is completely full. Then it says how much of the solution must be drained and replaced by 100% antifreeze to bring the solution up to 75% antifreeze. So we're going to drain some of the solution out. Okay, and then we're going to be left with part of it being 40% originally, and then we're going to add 100%. So for right now, I'm pretending that the two solutions aren't mixing. Okay, we don't know how much we drain and how much we replace. So since we know that, I'm going to define that as my variable. So I'm going to let X equal the volume of antifreeze, which is drained and then replaced, and that's going to be in quarts. So when it's replaced, this is actually going to be the volume of the 100% antifreeze. Okay, now let's see if we can put all the relevant information into the table to keep it organized. So the first column, we're going to put what we're mixing. So I'm just going to call them, for lack of any other better name, solution 1, solution 2. And when we mix them together, we're going to call them the mixture. The next column, we're going to say what's relevant about these solutions. One thing we need to know is the percent concentrate. So the second thing that we're dealing with is the volume, and in this case, that's in quarts. The third column is always the product, which will have different units depending on the application. Here, if we take the percent concentrate times the volume, we're actually going to end up with the volume of antifreeze, 100% antifreeze. And that's also going to be in quarts. But for our purposes, the product is sufficient. So let's fill in what we know. So for solution, so what do we know about percent concentrate? Solution 1, let's say that's what's originally in the radiator. So solution 1 has a concentration of 40%. Solution 2 is 100%. And the mixture, we want that to be 75%. So these are actually be 0.41 and 0.75 when we multiply. The volume, solution 1, we defined that volume as being, we defined the volume of solution 2 as being X. That's what we said was the amount that we drained and then replaced. That's going to be X. The mixture is actually taking up the entire radiator. So that's going to be a volume of 15 quarts, leaving solution 1, the amount of 40% that we have is going to be 15 minus X. Now we're going to multiply across. So when we do that, we're going to have 0.4 times 15 minus X, 1 times X, which will be X, and 0.75 times 15. Since we're mixing two things together, the sum of solution 1 plus solution 2 has to equal the mixture. So we have 0.4 times 15 minus X plus X has to equal 0.75 times 15. And if we multiply these out, 0.4 times 15 is 6. So 6 minus 0.4x plus x equals 0.75 times 15 is 11.25. Now we'll solve this linear equation. So we'll subtract 6 from both sides, and we'll have negative 0.4x plus x equals 5.25. Combining like terms on the left side, we'll get 0.6x equals 5.25. Dividing both sides by 0.6 gives us that x equals 8.75 quarts. So to finish this up, we should probably write a sentence. And so the result is that we should add, well, I guess it should be drain and replace 8.75 quarts.